This is the video for the 6.6 skills practice. So on your screen right now, you actually see the guided notes. This is what we did in our last class. So just to remind you, the unit we're on right now is about systems of inequalities. To be a solution to a system, points have to be a solution to both of the inequalities in the system. So in our skills practice today, we're going to be doing problems like that. For instance, number 1, we have two inequalities and we're looking for the solution to the system. The solution to the system has to be a solution to both this inequality and this inequality. So what we're going to do is we're going to graph both of these inequalities and then find the region of points that is a solution to both systems. So let's start by graphing y is greater than negative 1. Y is greater than negative 1 represents a line, and since it doesn't have an x in it, it just has a y in it, this represents a horizontal line. Remember the line y equals negative 1 would just be the horizontal line that goes through the point y is negative 1. But since this is a less than symbol, it's going to be a dotted line. So we're going to have a dotted line, dotted horizontal line going through negative 1. And now for shading, since it's a greater than symbol, we're going to be shading above the line. So I'm not going to shade this in very dark because this is only half of our problem. We're not quite done yet. So I'm just going to make a few notes here to myself to remind me that this line is shaded above. Now for the next inequality. This is x is less than 0, which is a vertical line at the point x is 0. And since it's a less than, it's going to be dotted. And since it's less than, we're also going to be shading to the left. Think of, normally we shade above or below, but with a vertical line you have to shade to the left or the right. Well, left is below. The negative numbers count to the left, the positive numbers count to the right. So to the right would be above, to the left is below. So this line gets shaded to the left. The solution to this system is the region of all the points that are solutions to both inequalities. So we're looking for a region that's both colored with blue and green, according to the way I drew it. Well, over here where I'm about to start erasing, these are green solutions, but they're not blue solutions. And down here, these are blue solutions, but they're not green solutions. The only region where we have solutions for both the blue inequality and the green inequality is this region over here on the top left. So this is what our answer would look like. Two dotted lines with a shaded region on the top left. You are going to try to do number 2 on your own. So let's move on to number 3. For number 3, we're going to do the same exact thing, but this time there are a few steps we have to take to draw each of these inequalities. So let's start with the first one. Our first inequality is already in the form y equals mx plus b. So we're going to use our m and our b to draw this line. Our b is positive 1, so that's our y-intercept, and our slope is 1, which gives us a rise over run of 1 over 1. So up 1, right 1, up 1, right 1, something like this. And you can take the pattern down in the other direction as well. Now let's draw the boundary line. This is a less than symbol, so it's going to be dotted or dashed. And since it's less than, we would shade this below. So I'm just going to draw a few light lines to indicate that we would shade this below. And now let's move on to our other line. This inequality is not written in the form y equals mx plus b, so we need to get it that way. Let's start by subtracting 3x from both sides. Then we'll have a 4y is greater than or equal to negative 3x plus 12. And to get that y by itself, we'll divide both sides by 4 That will leave us with y greater than or equal to -3/4 x plus 3. Now we can very easily pick out our m and our b. We start with our b, 1, 2, 3, that's our y-intercept, and then we use a slope of -3/4 to do a rise of -3 and a run of 4. Well, a rise of -3 goes down, so down 3 and right 4. Puts us right here for our second point. Since this is a greater than or equal to symbol, we are going to be drawing a solid line. And since it's a greater than, we will shade above the line. So that would be up here, above the line. Now let's try to figure out, based on our picture, which of these regions is our solution set. We need the region that is a solution to both the green and the blue problems. So all of these green solutions down here are out because they are not also blue solutions. And these blue solutions up here are out because they are not green solutions. So the region we're looking for is this area right here. That's a solution both to the green inequality and the blue inequality. And this is what your answer looks like. You'll have a dotted line, a solid line, and a shaded region on the right. Number 4 is a problem that you will do on your own. So let's move on to number 5. For number 5, we have a similar issue at the start. We're looking at an inequality that is not written in the form y equals mx plus b. So let's write it in that form. To do so, we need to move the 2x to the other side. So I'm going to subtract 2x from both sides. That will leave us with y is greater than or equal to -2x plus 1. Well, here's our m and here's our b. Let's draw our boundary line. Our y-intercept is +1 and our slope is -2/1. That's down 2, right 1. Down 2, right 1, continuing the pattern. Can take it up in the other direction as well. And looking at our inequality symbol, it contains an equal to component. So that means we're going to draw a solid line going through these points. Since it's a greater than or equal to, we would shade this above. So I'm going to do a little bit of light shading here. And moving on to the next inequality. Again, this is not in y equals mx plus b form. So let's get it in y equals mx plus b form. We'll start by subtracting x from both sides. On the right then, we'll have a -x minus 2. We don't have that y by itself yet because it's a negative y. We need just a regular positive y. So the next thing we need to do is divide both sides by -1. Caution. This is important. When you divide by a negative, the inequality reverses. It reverses direction. So on the left-hand side, we will have a positive y. Our inequality will reverse to become a less than or equal to symbol. And then the -x over -1 becomes a positive 1x and then a plus 2. So here's our m, here's our b. Let's draw. Our y-intercept is +2 and our slope is 1, or 1/1, you could say, for rise over 1. Since our inequality symbol has an equal to component, we're going to draw a solid line. And since it's a less than or equal to, we are going to shade below the blue line. Now it's time to figure out what region is our solution set. We are looking for the region that has both blue and green solutions in it. Remember, solutions to both lines. Well, these blue solutions down here are out because there are no green solutions down here. And these green solutions are out. But over here in this region, we have both green and blue solutions. So this is our answer. Number 6 is a problem that you will do on your own. Let's move on to number 7. Number 7 is a word problem. A lot of times in word problems, we're dealing with real-world situations where our numbers have some restrictions on them. For instance, if we're going to answer a question about tapes and CDs, and we end up with decimal numbers, that would be a little bit silly, right? We don't usually like to talk about a half of a CD. We're not going to break the CD in half or break the tape in half. So in a problem like this, if you end up with decimal numbers, you might have to do a little fudging to make sure that you're dealing with something that actually makes realistic sense within the context of the problem that you're doing. So number 7 is like that. In this example, Maria had $150 in gift certificates to spend at a record store. She bought no more than 20 items. Those items might consist of tapes or CDs. So tapes cost $5.95 and CDs cost $8.95. How many of each type of item might she have bought? So the first thing I'm going to do is actually give my variables names. On our graph here, since tapes are on the x-axis and CDs are on the y-axis, I'm going to call tapes x and CDs y. Based on the information from the problem, we can come up with a couple of inequalities to represent the information. The second sentence says, she bought no more than 20 items. Well, the number of tapes she bought plus the number of CDs she bought can be no more than 20. No more than translates to less than or equal to 20. The second sentence helps us figure out how much each tape and each CD costs. So let's think about the total amount of money that Maria spent. If she spent $5.95 per CD, that would be $5.95 times X, or 5.95 times X. And if she spent, I said CD, I meant tape, so 5.95 times X, which is the number of tapes. CDs cost $8.95, so 8.95 times the number of CDs represents how much money she spent on CDs. And if you add them together, this is the total amount of money she spent. We're told in the very first sentence that she had $150. So the total amount of money she spent has to be less than or equal to $150. So these, here and here, are our two inequalities. We have just set up a system of inequalities. Now, I want you to finish the rest of this problem on your own. So, using these two inequalities, get them in the form y is less than mx plus b, or it might be y is greater than mx plus b if things move around or change. Find your m, find your b, graph it, shade, and then find the region that satisfies both of these equations, just like in all of the examples we did above. And then don't forget, the very last instruction here tells you to list 3 possible solutions to the problem. Once you have your region all shaded in, all you have to do is pick any 3 points that are inside of that region. They will all be solutions, and you can pick any 3 points you want as long as they're inside of the region that satisfies both inequalities. So once you're done with that, snap a picture of your work and submit it on Canvas, and you are done for the day. Good luck!